where from the GD&T is originating. Are there any standards governing the GD&T? Yes, the GD&T is governed by ISME as well as ISO standards. ASME Y14.5, a earlier release was in 1994 and the latest release was in 2009, is the most popular standard followed worldwide across the engineering industries. An equivalent standard available in ISO is ISO 1101 2004 version, named as Geometrical Product Specifications GPS as per ISO. Then Indian standard 8000 is again based upon ISO as well as ASME standards. Now let us have a brief discussion on the main parameters coming under the GD&T spectrum. Right from flatness until symmetry, we have in total 14 parameters under the GD&T spectrum. I am sure some of the symbols you must be already quite familiar. Maybe some symbols, maybe the usage is bit rare. However, each symbol has a distinct meaning as well as a distinct application in engineering assemblies. Now look at the second column, wherein the 14 parameters are grouped into 5 different groups. As you can see here, the first 4 parameters are called as form parameters. Flatness, straightness, circularity and cylindricity are called as form parameters. Then the 3 parameters, parallelity, perpendicularity and angularity, are called as orientation group of parameters. Then we have the position, concentricity and symmetry coming under location group of parameters. Then you have runout. Then lastly you have the profile group of parameters. You may intend to ask, what is the basis of this grouping of the parameters? The first 4 parameters under form group, what is written in the first column, if you can observe, they are meant for individual features. That means they are referred to independent feature and no datums are applicable. Whereas the second group of parameters coming under orientation, you can read under the first column, they are called as related features. That means in all the 3 groups, like that is orientation, location as well as runout, datum references are must. It is simple to understand. Look at a plate, for example. Now when we say the bottom surface needs to be flat, we are not comparing the bottom surface with anything else on the part. The bottom surface needs to be flat. That means the bottom surface concavity and convexity, the ups and downs should be limited within certain value. That is why we say the flatness of this bottom surface is an independent parameter. It does not depend on anything else. Now let us come to the top surface. Now if we say top surface of this part should be parallel to the bottom surface of this part, then in this case the bottom surface becomes my reference. In GD&T language I call it as a datum. The top surface needs to be parallel with the bottom surface within given extent, say 0.5 millimeter or 0.1 millimeter as the application demands. In other words, the parallelism control becomes a relative control and always datums need to be mentioned. So that is the chief difference between the form group of parameters and the remaining groups of parameters. Form group of parameters, they don't require any datum references. They are applicable for individual features available in the part, whereas the last three groups coming under orientation, location and runout, they require datums in a compulsory manner. What is the group coming under profile? In the first column it is mentioned as it is applicable to either individual features or related features. What's the meaning? Profile controls can be applied with datums or without datums. If they are used without datums, they act more like a form control, and if they are used with datums, they act more like a location control. So this is in short a brief description about the 14 main parameters available under GD&T spectrum, and the groups are form, orientation, location, runout, then profile. Well, now we move on to the next slide, wherein some other symbols are mentioned coming under the heading of modifier symbols. That means in addition to the 14 main symbols what we have seen in the earlier slide, these symbols are called modifier symbols because these symbols modify either the shape of the tolerance zone or the value of the tolerance zone. Out of all the symbols, the most common symbol is this one, that is M symbol, standing for maximum material condition. The other symbols like L, which is signifying least material condition, the P, T, F, etc. are used a bit rarely, and of course the dia symbol is again common in some of the orientation parameters and location parameters. We will discuss the individual meaning of each symbol as we go along our discussion. In addition to the modifier symbols, we have yet another group of symbols called additional symbols, and these additional symbols, the sole purpose is to make the engineering drawing more neater and clutter free by minimizing your writings or what you call notes written in the drawing. There are symbols for counterbore as well as counterbore depth. Then there are symbols for countersink as well as counter